One of the things many of you may have observed while looking at these op-amp circuits which we have been discussing so far is that if you take the op-amp as a whole, it doesn't seem to obey Kirchhoff's current law. Okay? Here is what I mean. Let me take our usual amplifier circuit. If I have an input voltage Vi and this is K minus 1 R and R, the output will be K times Vi with an ideal op amp, and with a real op amp with a finite but very large gain, it will be close to this. Now, the current flowing through these resistors is Vi by R. It's KVI divided by the sum of these, which is Vi by R. Alternatively, Vi appears here also. So, the current through this is Vi by R, which also flows through that resistor. Okay. And obviously, this current comes out of the op amp. But the input of the op amp, both the inverting and non-inverting, draws zero current. Okay. The op amp draws no input current at all. So if I think of the op amp as a whole, we know that any closed surface should have the total current entering it or leaving it to be 0, and clearly here it is not 0. Okay. The current coming out of the op amp is Vi by R. In fact, I could add a load to it, and then a current KVI by RL will flow that way. So, the total current coming out would also include KVI by RL. It will be Vi by R plus K times Vi by RL, and these are 0. So, if you sum the currents there and there, let us say coming out of this closed surface, it is clearly not 0. Okay. So, this seems to violate KCL, which of course cannot be violated at all, but the resolution to this is pretty simple. In this picture, as in most op amp pictures, we have omitted the power supply connections. Okay. So, if we do include the power supply connections, this is VDD and this is VSS. Okay. So, the positive supply is connected to VDD, the negative supply to minus VSS with respect to this ground. Okay. So, the currents through these are clearly not 0. Okay. So, the current flows through the supply terminals. So, that is how the sum of these currents will get balanced. Okay. So, essentially the current that is coming out of the op amp is coming out of the supply terminals of the op amp. Now, exactly how much current flows through the supplies depends on the internal details of the op amp, but there is a pretty simple model that we can use, which I will discuss now. So, I have the positive and the negative supply. Okay. And the currents into the input terminal of the op amp are 0. And let us say the current that is coming out, it is called I out. Okay. And the current that is going into the positive supply terminal, I call it I plus. The current that is coming out of the negative supply terminal, I call that I minus. Okay. Now, a very simple model for this I plus and I minus is that I plus is some fixed value I naught plus I out. Okay. If I out is greater than 0. Okay. Rather, let me first put this condition. If I out is greater than 0, that is, a positive current is coming out of the op amp, then I plus is I naught plus I out, and I minus is just I naught. And if I out is smaller than 0, then I plus is just equal to I naught, and I minus will be I naught minus I out. Okay. So this first of all satisfies Kirchhoff's current law. Okay. And in fact, this is sort of a simple model, and not every op amp may obey this model. It could be that the current through the supplies is exactly a constant and so on. But usually there is a constant part, and there is a part that is dependent on how much current is being driven out. At least for general purpose op amps that you can buy off the shelf, such as the 741 or 347 or those op amps, this model is followed. Okay. And clearly, if I out exactly equals 0, then I plus and I minus will be the same and equal to I naught. This is a pretty simple model that we can use. Okay. So for instance, let's make an amplifier out of this. I won't work out the precise details. Okay. So let's say that the input is a sinusoid. The output voltage here also will be a sinusoid. So during these parts, I out will be positive, and during those parts, I out will be negative. Okay. So what happens is that in such a case, let's say V out swings positive and negative and positive and negative, then I plus will be following the sinusoidal current. Okay. Because the voltage is sinusoidal, the current is also sinusoidal. The I plus will be following this current, and when the output current is negative, it will just be the fixed value I naught, and then it will follow this and so on. And similarly, I minus will be, please note the direction of I plus and I minus. I have chosen I plus to be flowing into the terminal and I minus to be flowing out of the terminal. This is not the kind of convention I normally used, but these values are positive. That's why I use them like this. I minus will do the opposite. When the output voltage and hence the output current is negative, it will be a constant. Otherwise, it will follow the signal, and it does that. Okay. So first of all, KCL cannot be violated, and it is not violated in case of the op amp. The output current of the op amp comes from the supply terminals. Okay. Now, given any op amp circuit, from the circuit analysis, you know how much current is flowing out of the op amp. Now, if you want to get an estimate of how much current is flowing in the power supplies, you can use this model. And if the value of I naught is not given to you, you can even assume that to be 0, just to get a feel for how the currents in the supply terminals vary. Okay.